Okay, so now we're going to have a look at question 27C, and we're going to do this separately because it's a graphing question. So we've been told to sketch the curve y equals x times e to the minus 2x, showing any stationary points, points of inflection, and intercepts with the axes. So this is a slightly difficult thing to do. We just found from the last question that there is a stat point at the point 1/2 1 on 2e. So for this question, this is just a continuation of the last question. We have a max at 1/2 1 on 2e. So if we draw our graph, we'll draw it something like this. We might make this 1/2. E is close to 3. 2 times a number close to 3 is somewhere between 5 and 6. So this value is something like a sixth or something like that. So if this is 1/2, then a sixth will be somewhere down here. This will be 1 on 2e. So this will be a maximum. Now we could actually change the scale here. We might change the scale of both of the axes. We might make this 1/2. We might make this 1/2. And that makes a number somewhere down here is 1 on 2e. So we have a maximum here. Now, intercepts with the axes, well, it has to cut at 0. When x is 0, y is 0, so we know this happens. We also have to be careful to look for points of inflection. So we have an important intercept, we have an important min or max, we don't have any inflections. Now, this is an x value multiplied by a negative exponential. These have a particular shape. Some students will be familiar with the shape that these kind of curves have already. If you're not familiar with them, they usually look like an exponential on one end. The exponential takes over on one side, and then they usually either look similar to a line in part of it, or they're an exponential that turns in the opposite direction. So things like this, things like this, things like this, these are the sorts of shapes we're looking at here. Now, if we want to graph the connection between the origin and 1/2, we could find a few points in here if you wanted to. If you're in an exam, find a few points, but it is likely to smoothly curve. So it's going to curve something like this up to this point. This is a maximum. Now we need to find a point of inflection as well, if there are any. This will be the case where the second derivative is equal to 0. So we found the second derivative earlier. We said f double prime of x was equal to 4 times x minus 1 times e to the minus 2x. Got to let this equal 0 for inflections. Well, 4 can't equal 0. E to the minus 2x can't equal 0. So x minus 1, this has to be equal to 0. This implies when x is 1, there is an inflection point. We can plug this into the original function, f of x, which is x e to the minus 2x. We find the function evaluated at 1 is 1 times e to the minus 2. So this is 1 over e squared. And this is the y coordinate of the point of inflection. Now this is a smaller number than 1 on 2e. It's sort of maybe 2/3 of it. You could get a calculator and evaluate these, but it's sort of going to be here somewhere. 1 on e squared. 1 will be over here. So we have the point of inflection here. These are going to smoothly connect. Then when we have this kind of function, a linear function multiplied by an exponential, if it's a negative exponential, the exponential will take off at a certain point as it starts getting very small, so it will flatten out towards x. And you can look at it doing that if you want. You can examine points and take limits, etc. But this is known to be the case, right? So it's fairly common for people to say, oh, well, I know that this function has to do this. And this is certainly an approximate graph of what this function looks like. In terms of the marking, you get 1 mark for providing a sketch with a stationary point and one other feature. So if you do your graph, you've got your maximum, one other quality, so an intercept or something like that, you get 2 marks for sketching the curve with most of the main features. So if you have almost everything, you'll get 2 marks. 3 marks for a completely correct graph. This will include the intercept, the maximum or minimum, the inflection. You could also add what the graph does on the other side. So this graph will go downwards because the e with the negative power is always positive, but the x becomes negative. So when it passes through the origin, it will continue to curve downwards. We haven't exactly captured the curvature here, but you don't need to, right? If you were doing this in practice, you would be doing it on a computer. So this kind of thing, this is a pretty good graphical representation in this case.